While the majority of the mountain building in the western portion of North America had finished by the beginning of the Cenozoic with the orogeny of the Rocky Mountains, the Laramide orogeny ending in the Eocene, still more transformations occurred during the Cenozoic era. For example, while the Farallon plate, which had been so critical given that its subduction was a primary factor in the orogenies of mountains during the Mesozoic era, while that had primarily been subducted, a remnant of it, the Juan de Fuca plate, which still exists today, continued throughout the Cenozoic and continues today to subduct under the northwestern margin of North America, from California to British Columbia. And this subduction has resulted in the formation of the Cascade Mountains in the last 40 million years. This has been an active area in the Cenozoic, and all historic eruptions of volcanoes in the continental United States have occurred in the Cascade Mountains, such as in Mount St. Helens, pictured here. The subduction of plates has led to volcanic eruptions and the formation of island arcs outside the continental United States. In the Alaskan Aleutian Island chain, as the Pacific plate subducts underneath the North American plate, it is the most seismically active region in North America, with over 90 volcanoes which have erupted in the past 12,000 years, including 29 which have erupted in historical times. A hotspot, a presumed magma plume in the Pacific, continues to form geologic structures such as the Emperor chain of seamounts and the Hawaiian Islands. As the plates move over this hotspot, these islands and seamounts have been formed at different points in time. Not only can plates collide and converge, they can also diverge. This is evident in East Africa, as East Africa is rifting away from the remainder of Africa, but it is also evident in Mexico, where the Gulf of California rift zone has separated Baja California from Mexico starting in the Pliocene, where this area, which was once joined to Mexico, began to form ocean crust for the first time. It continues to move away from the rest of Mexico, and Southern California is threatened to be transformed in this plate movement as well. The movement of tectonic plates not only forms mountains, but contributes to many other geological processes. For example, sea level and the uplift in North America has been involved in whether Western North America formed a shallow sea or was dry land. In much of the Cretaceous period, a shallow sea known as the Western Interior Seaway covered Western North America, at times permitting a continual flow between the Caribbean and Gulf of Mexico to the Arctic, but at other times being closed off at one end, and at times being anoxic. The movement of plates and the blocking of ocean currents had a role in the ice ages of the past 2 million years, which also then led to the Great Lake Agassiz, the Glacial Lake, as the ice age glaciers melted.